I'd like to now take a look at uh, acetal hydrolysis, and we're going to specifically look at cyclic acetals here. Now, cyclic acetals can be hydrolyzed by using excess water with an H plus catalyst. In the previous example where we were actually forming the cyclic acetal, we would have probably taken measures to remove water from the reaction as it was formed and forced the formation of the cyclic acetal. If we're trying to hydrolyze the acetal, we want excess water present so that the hydrolysis will go forward. So let's take a look at how the mechanism works on this one. Alright, so the first step will be the H plus adding to be one of the oxygens, it doesn't really matter which. And then we need to recognize where we're going to go. We know that this group is going to have to end up leaving at some point. So I think it's natural to want to break this bond first. As a rule of thumb, whenever you form an O+, chances are a bond is going to break to that oxygen, and that bond is usually going to be different to the bond that you actually formed, the extra bond that caused the plus in the first place. And this is the natural one to break. Again, recognizing that this is going to go, we still need to use the water, and this will facilitate this leaving in a little bit. So we'll tack the C plus with the water. Now, as I said earlier, if we're going to do a proton transfer, it will be to a group that's going to leave, and this will help get rid of this group that we're talking about. So what I'm going to do is I'm going to have this O take a hydrogen from here, and again look at the way this is happening. We're forming a bond from this O to this H, and we're breaking the bond between this H and this O. Remember, these are going to be fairly close in space. Please go back and take a look at one of the earlier mini lectures where I did the non-cyclic acetals, and I explained this this concept. So take a look at that. Now that I've transferred the proton to that oxygen, I can have the leaving group leave. And that's going to allow us to form our ketone. Alright, so that can be done. The other way we can do this is we can do these last two steps in one step if we want to. I'll show you how to do that. and then that will give us the same products. So we'll get the ketone, we'll get our H plus back at the end, and we'll get our diol as well. So what I'm talking about is from here you can either do it in 2 steps, or from here you can do it in 1 step and get the products that way.